Hello, friends. You're welcome to another session on Code with Matt. If you are yet to subscribe to this channel, please kindly hit the subscribe button. And if you like what you are watching on this channel, please, I want you to always click on the like button. That is how you encourage me to keep on producing more videos. I love it when I see you liking my videos. Thank you very much. So we've started a series on learning how to program in C. The last time we looked at the compilation process of a C program. Today we want to dive deeper. We want to continue learning the basics, learning the foundation of C programming. And this time around, we want to look at a very important topic. We want to discuss variables. We want to talk about data types in C. I want you to hang on with me and I want you to enjoy the process. You are going to code more. Please, if you can grab your computers, sit down, and then let's code together and learn together. Thank you. So, what are variables? Variables are an integral part of any programming language. It's not just in C. You come across variables in Python, variables in JavaScript, and any language you want. Even in Bash scripting, there are variables. So a variable is a data item with a specific name that is used to hold in memory. It's used to hold the particular data in memory throughout the runtime of a program. So a variable will hold something in the memory throughout the runtime of your program. The value stored in a variable may be changeable in the course of your program. However, you could decide to have a constant. A constant is a type of variable that will not change. And constants will, you want to write a constant, in C, you must use the const keyword, which we'll look at shortly. You will use a const keyword, and then it is best to name your constant in uppercase. Write the name in uppercase. However, and then there's to continue. Data types is just the attribute of the data that you are storing inside your variable. So that is what data type is. You need to tell us the attribute of that data. Let us know. Let the compiler know, not human beings. The compiler. So C is a compiled language and it is statically typed. So it wants you to define the type of data that you are storing in any variable, or the type of data that your function will return. So that is what it means to be statically typed. So it is strict, it is rigid. If you call a variable, if you say a variable is going to hold an integer, C expects that throughout your program, that variable will be an integer. If you try to put any other variable, if it's a float, for example, we'll talk about this, it will, by the time you're accessing it, it's going to give you the value. The integer part of the float is what C is going to give to you. So you need to be careful and you need to understand this concept. So the different data types, there are different data types in C. There is the int, that's int stands for integer. The int stands for integer. And then you could have different variations of integers. You can have the long, you can have the long, you can have the short. So all these variations actually, it's just a way, it depends on the length or the size of the data you want to store in the integer. So remember, at the beginning of this tutorial, I said something about memory management in C. So because C wants you to minimize memory as much as possible. For example, if you are programming an embedded software, an embedded system is not going to have large memory capacity. If you are trying to program an automated system, Internet of Things, all these things will not have access to large amount of memory like the RAM you have on your computers. You're not going to be having 4 gig memory space. You're not going to be having 8 gig memory, RAM memory accessible to your program. So C wants you to, okay, like think about it from beforehand. This is what I want to store. For example, I just want to store a value, maybe a value that is less than 100, less than 1,000. So C is going to like, okay, you are going to store this value. You know the limit of your value. So use don't use so much memory space that would be needed for larger values. So C wants you to manage your your memory space as much as possible. So the term long, short. So these terms are actually to help the compiler limit the amount of memory that will be allocated for that variable. So apart from int, you have char. Char stands for, or you can call it char, whichever one. It stands for character. So a character, characters are A, B, C, full stop, comma. All these are characters. They are also a data type in C. But if you want to think about it, a character is actually a type is actually a data type. Is actually a data type in C. A character is actually a type of integer in C. It's actually a type of integer in C. We will look at their memory spaces and then you will see where a character falls into place. And then we would also try to understand how characters come to be. For us to understand characters, we start talking about ASCII codes and all those things are things we will discuss. We will discuss them in details later on. So other data types, floats are floating point values. Those are fractional values. For example, 1.2, 0.4. So these are floating point values. Doubles are also floating point values, but they take more, they have larger memory allocations than float. And doubles there could be a variation, long double. So they have larger memory allocation and then a wider capacity of decimal points. Then Boolean values represented by bool, that is true or false. And then void. So void is actually a data type, and it actually means the data type has no qualification. That is void. So void is just like it's nothing. So in a situation of data types, now you are saying there is no defined data type for this. And of course, you cannot use void all the time. You cannot start a variable and say void A equals to no. It's not going to work. So, but there are times that you would have to use void. For example, if you have a function that is not going to return any value, then void would be used. Then when you start talking about pointers, we will talk more about void when we want to point to a particular location in memory without having to specify data types. We'll talk about this later in the tutorial. So what should we note? So int, char, floats, doubles may be signed or unsigned. So there is this signed or unsigned. So signed values are rather the natural and default, and that is when you are telling the computer, your compiler, that the values may be positive or negative. while unsigned values will shift the memory allocated to only taking positive values. So we'll look at this concept in the next slide. So you can see for a char gets allocated 8 bits. That's 1 byte of memory. 8 bits equals to 1 byte. 1 byte of memory is assigned for char. And then it can take from minus 127 to 127. So you can see that the char right there says minimum range, and then the minimum range is actually an integer value. So that is what I was saying concerning char. Char is a type of integer. But if you compare the size, the memory size of integer, which is either 16 or 32 bits, so depending on the architecture of your computer, so you can see it differs from char, which is 8 bits. So a char takes 1 byte of memory, and an integer can either take 2 bytes or 4 bytes, depending on your computer architecture. So why is it that characters in C are actually integers? This is something that brings confusion to a lot of students trying to understand C. And a lot happened that, you see, computers were not created with computers. Computers were developed by human beings. And English language is something that came, it's a human language, right? So it existed far before computers were made. So what happened is that um, an association came together and developed what we call ASCII, what we call the ASCII table. So ASCII stands for American Standard Code for Information Interchange. So they came and then they laid the standard. The standard that was laid is what became the characters in C. There are newer standards right now. For example, Unicode. With Unicode, now you can represent emojis. But before, emojis were not considered. So in ASCII, you will not find any code for emojis. But in Unicode, you see different representations of emojis. But C uses ASCII. The standard of C is actually ASCII. So the characters were represented like this. If you can check, you can see that it starts from 0. Starts from 0. Just trying to use my pointer. Starts from 0 and then ends at 127. So going back to the previous slide, you can see characters are represented from the char is from minus 127 to 127. So 0 stands for the null byte. We'll talk about the null byte later. All of these are different representations. Then talking about readable characters, from 32, which is space, 33, which is the exclamation mark. So all the way. So you can see ASCII representation of even numbers, written numbers, number characters, 0 to 9, starting from 48. So all of these things is just a way for, since the computer understands just binaries, so these decimals can be converted to binaries, and then the binary values is what will now point to the characters. So when you have a character 0, it has a binary number, and that binary number is a conversion of 48. So also you will see the hexadecimal values. So you may need to also understand hexadecimal. So, but what you should take home is that every character has a representation. It can be represented as an integer, and then we will see this in practical form very, very soon. So back to sorry, back to this table. So you can see the char 8 bits, and then this is the range, and then it can be unsigned, right? The unsigned, when you use unsigned, you're trying to say that, okay, I don't care about negative values. So what the unsigned does is the range now on the positive side becomes doubled, because on the negative side is ignored. So the range on the positive side becomes doubled. So you see 0 to 255 instead of minus 127 to 127. The same thing for integers. So this is the unsigned. You see the unsigned has a doubled range. The unsigned has a doubled range. So that is what I wanted us to understand about signed and unsigned. And then you can see that when you're now calling long, the long int, it's no longer 16 or 32. So but long int now is 32 bits, and then long int is 64 bits. So these are things that you need to understand. These memories values may vary based on the architecture. And as we get coding, I'm going to show us how we can know the size that our compiler will allocate for our variables as we start coding. So that is all about. You can go through this table and then you will understand. So floating point values, you can see them. They are represented with exponentials, and then they have different precision ranges. So just if normal a regular float has 6 digits precision, a double has 10 digits precision, and then a long double has 10 digits precision. So it just you use any of these the based on the kind of values that you want to represent. So if you feel you're going to have to deal with very large data, for example, maybe you're going to deal with numbers that are 9 zeros, for example, you may be thinking of using a long. So that is just the application of this. Because if you use something that is if you try to use a data type that takes lesser amount of memory than the value you want to represent, there is going to be an overflowing. So you are going to have wrong value. So you are going to have a wrong value at the end of the day. So that is the implication of using smaller data types than what you actually need. But if you use more than what you need, when you have to program for devices, when you're programming on devices that have limited amount of memory space, then you you would overuse the available memory space. So you have to learn to balance the two. All right. So little note on Boolean values. So the falsy and the truthy values. So Boolean values are either true or false. And one thing that we need to understand that Booleans evaluate to integer 0 if false, or evaluate to 1 if true. So you could actually use, instead of writing true or false, you could actually use 0 or 1 in your conditional statement. So, but other values may evaluate to true or false in conditional statements. And this is where we have the concept of falsy values and truthy values. Truthy values will evaluate to true. That means they will evaluate to 1 in your conditional. And falsy values will evaluate to false. That is 0 in your conditionals. So what are values that are considered truthy values? So any integer float or anything that is not equal to 0 will be truthy. So it may be negative, it may be positive. So long as it's not 0, it will be a truthy value. If it is not null, for example, when we start discussing pointers, if it is not null, that means there is a value located at that location in the memory, or it's an array. All of this we will talk about, then it will evaluate to true. However, when however, a falsy value is anything that will evaluate to false, and that could be 0, null, or when the value is actually absent, then it evaluates to false. All right, so enough with the talking. Let's see some of these things practiced in our code. All right. Okay, so let's create a new file. I can actually delete all of this. Okay, so let's create a new file. Let's call this data types. Let's see. Okay, so let's include our standard input. So standard io.h. So that will do. Let's create our main function. Right now, we're not using the prototypes. We're not using we're not using the parameters for main. So what I want to do is so first of all, we want to have a variable. Let's start with integers. So the way you write out the variable is you first call the data type, you first type out the data type int, then the name. So let's just say number, num, or decimal number. Let's just use decimal number. So one thing that you must understand is never name, you cannot, the name of your variable cannot start with a number. That will be wrong. Cannot start with a dot. That will be wrong. Cannot start with a token that is understandable by the computer. For example, semicolon, exclamation mark. So, but you can start with you can start with underscore. You can start with an underscore, of course, and then you can start with alphabetic characters. However, in between you can have numbers, but you cannot have anything that amounts to a token. You cannot not have anything that amounts to a token that means something else to the computer. So int, decimal number. So there are two ways to do this. You could just declare this and not give it a value yet. So if you do this, it means that somewhere in your program, you are going to give it a value. So I can say here, decimal number equals to 10. Of course, remember to end with a semicolon. So now this, when you assign a value to a variable, what it means is that you have initialized the variable. Now I could have another, I could say float um, float fractional number, let me just say fractional equals 5 point, and then I can write this in another way. I could still say float another equals 7 exponential 10, or I can say 7 exponential 1.5. No, sorry, that's wrong. Yes, I could say 7 exponential 10. That's correct. Or 7 exponential minus 4. That is also correct. So I want to print these values. So still using printf. We'll discuss more about printf in later sessions. So integer is, or let me put it this way instead. And a new line, fractional is, a new line, another is. So we have our values. We're passing in decimal number, fractional, and another. All right, guys. So let's try to run this. So remember, we need to return. So let's compile. If you have not seen the video on the compilation process, please kindly check the playlist or check through the channel. You will see the video on compilation process. So GCC data types, and then the output is DT. Okay, so compile successfully. So let's run the program. Okay. Oh, I missed out a new line here. So let's correct that. So we compile again and then we run. Okay, so the decimal number is 10, of course. You can see that the fractional number is 5.765432. Wow, why did it stop at 2? How many decimal places do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7, 8. So this is larger than what a float can take. Can you see now? This is larger than what a float can take. So we need to go and make adjustments. And then another is 0.000700. So we wrote this as an exponential, right? And then look at the value we get. So let's make an adjustment. Let's call this a double. So let's, that is, I need to change this to, okay, let's run this. Okay, so let's use, where is it? Let's use the LF flag. Do we have a longer fractional double? We still have a limited, we are still limited to, okay, so let's clear this. Let's try to specify the number of outputs we want. So let's say we want 10 decimal places. So dot 10. So we'll discuss more about printf later. These are things you can do with printf. So if we run the program, so we see we have this to 10 decimal places. Okay, so putting this as double. Okay, can you see we have it up to 10 decimal places? 5.7 is up to 10 decimal places. So let's see if we can get this longer. There are 14, right? So let's try 14.14. Okay, so we have 3, 4, 5, and then it adds a 0. So it's able to take everything complete. It's able to get everything completely out for us. So that's the beauty of using a larger capacity. But what if I try a float and keep our 10 decimal places? So you can see I've kept 14 decimal places, and then you are saying that this is not what is here. This value is different. The value is totally different from what we have. In fact, it's correct up to 765,432. Then after that 2, it starts giving us rubbish. So the reason is that we have gone beyond what the floating point of float can take. So if you try to use a float to represent such a data value with longer decimal numbers, then it's going to fail. You're going to start having errors. So to correct this, we need something longer. So we use a double. And then by the time we try to compile again, you see that we get it right this time around. So this is supposed to be 13. So there are 13 decimal points there. So, but of course, there will not be a problem if I want that number converted to two decimal places. So this is going to work properly. So it works for 5.77. So 765 gets approximated to 5.77. So if I also have this as just a float, so you see we still get 5.77. So it performs well, but by the time you need a longer precision, you need more data, more decimal values, you are going to start seeing the limitation of float. So the same thing goes for this decimal number. If I were to change this to, let's try to represent 2, 3, 4, 5, 6, 7, 8. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9, I believe that's a billion. Let's see. Okay, so our integer is able to take a billion, right? So let me add another zero. And let's try to see the limitation. Oh, you can see my compiler is already warning me. So warning, overflowing conversion from long int to int. So this is already telling you, the compiler is already warning me that the value I've entered cannot stay in an int. It has to be in a long int. But because I didn't use any flag to compile, so it still went ahead to compile, but with a warning. So by the time I run this, you can see that this number is not correct. This number is not correct. So it has overflown. It's not correct. So it's going to give me an error. So to correct this, if I know that I'm going to have a value that is longer than what an integer can take, then I might as well just use a long. And then by the time I come back here, I'm going to change this. I'm going to add the L to it. So you see compile successful, and then I have what I wrote. So that explains integers, numbers. So other data types are, you can have bool. Bool. You can say bool is C equals true. No, sorry, this has to be capitalized. Something. Okay, so you can see that there are, excuse me, you can see that there are some errors showing up right now. See, this boolean data type was actually an addition to C. It was not there from the onset. And then true or false was actually being represented by zeros and ones. So, but for you to have this boolean working, then you have to include another header file. And this header file is actually called stdbool.h. So standard bool. So stdbool.h. So once you have included that, then you can see that this is working. So we can now say bool is not C equals, of course, this will be false. Okay, so let's print out, let's see our values. So is C is, so like I told you before that they are integers, right? And then we can say is not C, is send D, and then we print a new line. So our values are is C and is not C. So if we run this, compiles, so you can see is C is 1, is not C is 0. So false is 0 and true is 1. So that is for us to understand. So with booleans, you see the concept of conditionals, right? So you can have, we can change this, say if, and then put in brackets is C. So if is C, do something. So in there we can say if is C, print is C. And let's remove all of this. Let's remove all of this. So the value of is C is what? Is going to be true. And then we can say if is not C. So if it's not C, also let's do something. Let's say print is not C. So by the time we run this, let's compile. Let's run. So the only thing that gets printed is C. Let me put a new line. So we can compile this again, and then we have our desired output. So you can see the only thing that gets printed is C. And the reason is that is C becomes 1 and is not C is false, is 0. So because this evaluates to false, then it's not going to print. But if I change this to if is C also, which is true, right? So you are going to say that this code is going to the two statements, or the two statements will be printed. So is C is not C will be printed. So that is the use of booleans for you to evaluate conditions, right? So we'll discuss about this if statements later on. So down to the last one we should consider, which is char. We need to consider char, right? So for us to have char, we can say char alpha equals to, now let's use character. So if you want to represent a char, you will use single quotes. So the capital letter A. So let's see this. So printf. So we could just say alpha is to send C. That's what we use to print out alphabets, that's characters, and then we use n, and then we can now put alpha here. So by the time we compile this and then we run it, you can see alpha is A. Alpha is A. So the other time I said characters are numbers, right? Characters are numbers. So let me have an integer here. So int, let me just call it J, right? Equals to 10. So then I can also say int k equals J plus alpha. So I want us to see the numerical value of alpha first. So printf, so numerical value of alpha is, so we use, instead of %c, let's use %d, and then print a new line. And then we can now say the value of j is, and then new line. And then, so we now said k is j plus alpha, right? So we can now say value of k is another %d and the new line. So our first is alpha. So we pass alpha. Sorry, there should be a comma. The next is j, and then k. So we end with the semicolon. Let's compile and let's run it. So you can see the value of alpha is A. The numerical value of alpha, which is letter A, right? Capital letter A, is 65. So the other time, let's go back. Let's go back to our presentation. Let's have a look at the ASCII table. On the ASCII table, using my mouse pointer, let's see the capital letter A. This is the car, you can see, or the char. The capital letter A is represented by the decimal number 65. So going back to our code, you can see that the value of A, capital letter A, is 65. So you can do some arithmetic with it. So J is 10, right? J is 10. And then K is 10 plus 65. That is 75. Okay, so what if I want to find out the character that is 10th place from alpha? So that will move on the ASCII table from A, which is 65, to 65 plus 10. 65 plus 10 is 75. So that is K. So let's see that on our code. Let's see that on our code. Okay, so we can say we want to have the character that is 10th place from alpha, which is A, right? So let's see that here. So 10th character from alpha. So we use our %C, and then a new line. And of course, we want the character value of K, which is 75. So we are still going to use K, right? And then this time around, we will compile again. And then voila. So 10th character from alpha is K. That K is 75. On our ASCII table, K stands for K is 75. So that is why we can print K even though we declared an integer. So what are your caveats? If I want to do something, right? Maybe I want a value that is I know that my value is less than 127. So I can use 10. I can use 10, right? And then I can just print this and then use this for integer values. So what would have happened is that I would have saved memory because my value would not be stored in the value of an integer, which may be 4 bytes, depending on your system. It may be 2 bytes on your system, it's 32 bits. But on my own system, I know it's 4 bytes. So we'll talk about this, how to get these values most likely in the next lesson. So I can use this to save bytes and just say char alpha 10, or I can say char alpha, and then I could just even represent this as 1. So this is going to work. But of course, if this is going to be more than 127, let's say I have 128, then there is going to be an issue. Another way I can go around that, of course, if I use sign. Sorry, if I use unsigned, the default is signed, right? So if I use unsigned, so this can take up to 255. So, but anything more than this is going to be a problem. So it's better to just use integer. So whichever way you're going to use this, of course, it's going to be determined by the memory space. You plan your program before you start coding. So in C, you have to prepare ahead. You plan your program before you start coding. So when you know the limit to the values you have, right? So that will now determine the data type you want to use, whether you want to use char, whether you want to use int, long, signed or unsigned. It depends on what you are expecting. Do you understand? So that is just what you need to understand about that. Then of course a word about constants. So if I want to make this a constant, meaning it's not going to change again, right? So if I say const int, so it's best rather than just saying j, it's best for you to actually have a definite name for your constants. So for example, maybe I want the constant to be buffer size. So I'll put it in capital letter and then I'll write it in full, buffer size. So maybe I want my buffer size to be maybe I want it to be how many bytes? Let's say I want 128 bytes as my buffer size. So this is never going to change. So in fact, if I try to change it, If I try to change it later, to now say buffer size equals to 60. So note that I've used the const keyword and then I've declared it. And then even right here, my VS Code is already saying what? Expression must be a modifiable left value. So, and then it's showing me that, look, oh, you have used const. So this cannot change. If I try to compile, you see error, error, error. So the first error is that J is not declared. Oh, sorry, I changed that. So that's the error there. So that means I don't need the value of J. So I can actually remove all of this. I can remove this line. So let me try again. So you can see error, assignment of a read-only variable buffer size. So once you declare a constant, you cannot change it. So that is just what you should take home from this. So, and then to declare a buffer size, you have to use the const. So if you try to change a buffer size, it's going to be a bug and then it will not compile. So, and then it's good like that because you are setting a constant so that you will not change it. You are saying that this value is unchangeable. And another application is, of course, if you have the float pi, right? So maybe you have a float. I can't remember the value of pi right now. Sure, it's 3 point something 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 something. So you put it in capital letter and then you indicate 3.11 something 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 something. So that is the value of pi. Let's just say this is the value of pi. So of course that is not going to change. So you can now say something like area now float area equals, I remember it's pi r square, right? So pi times, so maybe the radius is 4 centimeters, right? And then multiplied by 4 centimeters. So let's say this. So you can now print area. You can now say area is. So of course, here you use a float. So let's say we want it in 2 decimal places. So percent 2 and dot 2. And then we call this we use area here. So of course we don't need this anymore. Oops, sorry. So of course you compile this. So it gives you the value of the area. So what you just need to understand, what I want you to just understand is, by the time you have this pi is never going to change. So in your program, you can just keep on calling pi because it's a constant. You will never change it. But you cannot you cannot go and do pi equals to something later, and then this is going to result in an error. So it's already a warning. So you need to understand that. All right. So it's been a wonderful time. Thank you for staying this long in this session. It's been wonderful talking about data types and variables. Next time on Code with Matt, we will look at operators in C language. So it's going to be another wonderful time. We're going to deep dive into the concept, and I'll try as much as possible to give you good understanding. Thank you very much for your time. Please like this video and subscribe to our channel. And of course, share with your friends, share with your loved ones. See you next time.